ladies and gentlemen, and welcome to Rutronik Connects, our Rutronik webinar series. My name is Julian Klaus. I'm a corporate product manager at Rutronik in the wireless department. And today I'm your host for today's cellular webinar session called DECT NR+, the world's first non-cellular 5G standard. For those of you who don't know the Rutronik Connects webinar series yet, so Rutronik is doing a webinar series of a total of 4 weeks, and in each week we are presenting, and also our partner suppliers are presenting technologies and market trends of a certain wireless technology. For example, the first week was all about Wi-Fi. This week is obviously, as you can see in the slides, it's all about cellular and GNSS and locationing stuff. And in about 2 weeks, we will have another session about ultra-wideband, LoRa, and some mixed technologies, also edge machine learning, for example. And the last week will be in November, all about Bluetooth. So today, I have prepared, one sec, today the presentation will go about 45 minutes with a question and answer session afterwards. So if you have any questions, feel free to use the chat or the question and answer sector at the right-hand side on Microsoft Teams. The presentation will get recorded, so you can watch the video on demand anytime or pass it forward to your colleagues if you want to. And so that's what you can expect. And today, especially for DECT NR+, I have an expert from Nordic Semiconductor in-house. We have Heidi Irene Soli, who is Senior Product Manager or Product Marketing Engineer at Nordic Semiconductor, and she will tell you all about the new standard DECT NR+, and what are the benefits, and if we have time left, maybe a small demo. So Heidi, would you like to introduce yourself again?
Yes, thank you, Julian.
Great.
Hi, everyone. My name is Heidi, and I'm a Senior Product Marketing Engineer here at Nordic Semiconductor, and I work with Cellular and now NR+, which is a new rising standard. Should I just go ahead with the presentation?
Yes, please.
Yes, okay.
All right.
So, today I'm going to give a short introduction to DECT NR+, the world's first non-cellular 5G standard, and hopefully make you understand why this session is in the cellular block with the Rutronik webinar series. So the agenda for today, first I'll give an overview of the DECT NR+ standard, features and benefits and application areas that are relevant. And then I'm going to dive into some technical details about the standard, go into more specifically the network protocol layers, what do the different layers do, some of the very important features and where they're located there. And then lastly, I want to talk about what Nordic is offering with regard to NR+, both on the software side and on the hardware side. And then at the end, of course, a Q&A session. So please, if you have any questions during the presentation, just go ahead and type it into the chat, and then we'll get to that at the end. So first, for the overview. So the story today, or the situation today, is that there are many competing radio standards for IoT use cases. Some of them solve certain specific application areas. Some of them try to solve a few more. And NR+ is one of these standards that are trying to solve a wide area of application use cases. So the standard itself originates from DECT, digitally enhanced cordless telephones, which anybody who was around in the 90s remembers these these telephones that everybody had in their homes. But then there was, they saw an opportunity to use this existing spectrum allocation. The DECT frequency spectrum is allocated to the DECT technology and is quite free in many areas in the world right now. So they developed DECT NR+, which is a radio standard targeted more towards IoT applications instead of DECT, which is more for voice. And Nordic is leveraging our cellular technology, the NRF91 series, to be able to support the NR+ standard, because it reuses a lot of cellular techniques. So the modem in the NRF91 series is necessary to make this possible. And it is a new radio standard that came out a few years ago, and we believe it fills a gap in the IoT ecosystem when it comes to massive networks, networks that need millions and millions of devices, that need reliability, but also where you can scale very fast, start with a few nodes and add many more quickly and inexpensively. So that's where NR+ fits in the current IoT landscape. As for key features, DECT NR+ has a self-healing property. It has a self-organizing topology where the nodes in the network can change roles based on network needs, which means it's ideal for environments where there are a lot of moving parts. Many of the devices are moving around, where there can be congestion issues, so which is eliminated with a self-healing property where networks or devices can independently reroute packets. And it is also decentralized. It supports autonomous mesh topology, and there's no centralized control, meaning each individual device reroutes or routes packets based on the shortest or best connection, and each node makes these decisions autonomously. So there is no centralized control of a gateway steering the network. The devices do this themselves. It also has very low latency. It can achieve down to 1 millisecond latency on the packet level, and it is highly scalable. So 100 nodes can cover 1 square kilometer, and then you can also scale that up. So the same to 1 million nodes, that covers the same square kilometer. So those are some of the important features. And then as for benefits, there is a very low cost of ownership, because this is a network where you don't need any base stations or SIM cards like in cellular. You don't need a subscription to a network carrier. And since the frequency band is free, you don't need to deal with that. And it is also very easy to install. It is scalable and reliable. So as I said, with the features, it is completely autonomous, and it has support for security and over-the-air updates. And it can scale very quickly, and you get over 99.99% reliability on packet delivery in the lower layers. So that is handled by the lower layers of the radio stack, thereby offloading the application. And then lastly, you get access to this license exempt frequency band. So the 1.9 gigahertz DECT band is allocated to the DECT technology in most areas of the world. And this is a license exempt frequency, so you don't have to pay anyone to use it as long as it is a DECT technology. This frequency band is accessible to the application. So as I said, the main story here is that NR+ is a radio standard that is uniquely suited for large networks with millions of devices. where you still need reliability and low latency. And because it is decentralized, scaling the network quickly and inexpensively is almost as easy as adding a device and turning it on. So for applications where we see that NR Plus can fit in, we have a few. Industrial IoT is one. Industrial IoT where you need reliability and security, and you need a connection that is almost matched to a connection with wires. So large factories, warehouses, smart buildings, moving robotics where you have a lot of moving parts and a very high probability of congestion problems arising. And then for smart metering as well, electricity metering, water metering, any kind of utility metering where you have a huge number of nodes that are covering a large area. Smart city, smart street lighting, and parking, traffic management, bin collection, where you need many devices, you need high data rates, you need long range, and again, this reliability. And these are the initial focus areas for Nordic. But then you also have professional audio as a very good application, since NR Plus has this basis in DECT with audio. DECT NR Plus can bring improvements in that area to first for existing DECT applications that are already out in the market, but then also for new professional audio applications. So you have large arenas and stadiums where you need a lot of wireless audio receivers. You can get high bit rates for the same density, up to 24-bit professional quality audio. So for industrial IoT, here is a image showing, kind of giving you a impression of what that would look like. Imagine self-driving factory vehicles, for example, where you have cars on a moving or on a factory floor moving around a lot, where you need all the devices to stay connected at all times. Any application where you need a massive amount of connected equipment and where you have strict low latency requirements and where you need this self-healing and self-organizing property because the devices are moving around. You could get congestion issues, or if a gateway goes down, you would need the devices to automatically reroute to another gateway. And you also need, of course, a secure and private network. For smart metering, there are already a lot of deployed smart metering solutions, but these are all proprietary and there's a lot of different solutions out there. So NR Plus in this space offers a standardized alternative to existing proprietary solutions. And as I said, it's easily scalable, so you can start with a small number of nodes, deploy a few meters in a constrained area, and then scale up to millions very easily at a very low cost. And the mesh topology of NR Plus allows for a connection of different local clusters. And again, you can have a worldwide deployment of one solution because it is on the 1.9 gigahertz band. For smart city, NR Plus is ideal for example, for real-time monitoring of small microcities like campuses or airports, retail centers. You also have support for high concentration of diverse use cases. You can, for example, set up kind of an NR Plus infrastructure in smart streetlights and then be able to add other different applications like parking or video monitoring or waste management, where you have the NR Plus infrastructure in place, and then, for example, a backhaul to the internet with LTE and more narrowband IoT, cellular connections, or Ethernet connections. So for Smart City, NR Plus offers this opportunity to set up a very reliable infrastructure with a huge capacity for adding many different use cases. And then for professional audio, so as I said, that's wireless microphones, in-ear monitoring, audio for video, intercom headsets. Because of the high density, you can deploy NR Plus in large arenas and stadiums. And you get better quality audio than with legacy DECT. So that was kind of an overview of NR Plus, what it can offer, where we think that it fits in the current radio technology landscape. But now let's get into some of the more technical details of the standard itself. So in the beginning, I said that NR Plus is the world's first non-cellular 5G technology. And I thought I would talk a bit more about what that actually means. So 5G is very up in the air right now in terms of, the rollout of cellular infrastructure. But 5G itself is a document. It is a set of requirements and guidelines in a document called the IMT 2020 document that is determined by the ITUR. And it is basically a set of requirements for the next generation of telecommunication devices to meet. 3GPP and ETSI are two organizations that develop radio access technologies to meet the requirements. So 3GPP, which anybody in the cellular space is familiar with, develops 5G NR, 5G new radio, as well as LTE, CADM1, and narrowband IoT. And then ETSI has developed DECT 2020 new radio, which is now being marketed under the name NR Plus. So the IMT 2020 defines 3 different application areas for the next generation of devices, which is presented in this triangle here. So at the top, we have enhanced mobile broadband. This is applications where you want to see a increased capacity for bandwidth and data rate, augmented reality, video, virtual reality, where you want a high ability to stream data or download and watch data. And this is where 5G new radio fits in. And then at the bottom, we have massive machine type communication and ultra reliable low latency communication. So massive machine type communication are networks that need to connect a massive number of low power constrained devices, where you need dense networks, you need scalability, but low power consumption and low data rate. So it's a small amount of data being transmitted by many, many nodes. And this is where LTE-M and narrowband IoT, so the cellular IoT technologies, already fit in. They meet this criteria. And then you have ultra reliable low latency communication, which is a critical use cases, emergency use cases where you need high reliability. There is no option for failure. Say autonomous vehicles, remote surgery, critical infrastructure, robots, where the requirement is 1 millisecond latency on a packet level and a very high reliability on packet delivery as well. And NR Plus has been approved as a 5G technology for the bottom 2 categories, so it can meet the requirements for massive machine type communication as well as ultra reliable low latency communication. As for the dedicated NR plus spectrum, it is the 1.9 gigahertz band, and it allows for a single product to be deployed worldwide, which removes the cost of the producer to create and maintain product versions for different regions. So as you can see, there is a list of where the 1.9 gigahertz band is allocated in the different areas. And NR Plus also provides coexistence with legacy DECT on the DECT band. There are some areas where there is still work being done. The DECT forum has regulatory groups that work on protecting the 1.9 gigahertz band and also for expanding it for different areas. Here is the DECT band world map, which is a view of the areas in the world that have the 1.9 gigahertz band allocated to the DECT technology. And then I thought I would talk a bit about the network protocol layers that are in the NR Plus radio stack. There's a PHY and then a MAC and a DLC and a convergence layer. And I thought I would just present some of the key things that the different layers handle. So NR Plus uses orthogonal frequency division multiplexing as the modulation for uplink and downlink with multiple input, multiple output support. This gives us a nominal bandwidth scaling from 1.728 megahertz, which is the bandwidth supported by Nordic solution. And it also gives us a subcarrier spacing of 27 kilohertz. It also has support for HARC, hybrid automatic repeat request methodology, which is what improves the reliability of the standard. Because this is handled by the bottom layer of the stack, so the application layer does not need to handle the retransmissions. This happens on the lower layers. As for the MAC layer, which handles the network topology, NR Plus networks have 3 roles. You have the sink, which is the gateway to the internet, which is where all the packets are rerouted, and which typically will have either a cellular connection or an Ethernet connection to the internet. And then you have relay nodes, which extend the network by routing messages to the clusters. So every cluster has a relay node that is in charge of routing the packets. And then lastly, you have the leaf nodes, which just send and receive data. So this would be, for example, your sensor devices would be a leaf node. There's support for point-to-point, star, and mesh topology. And the relay nodes also have this interference avoidance feature where they can utilize different channels within the specified operating frequency controlled by the relay node in the clusters. Device roles are appointed anonymously and can support device provisioning and self-organizing and self-healing features, as I said. So this is something that the standard offers, but that is not required. And the all NR Plus networks have a network ID. And every radio device has a radio device ID. And the standard is built so that a network ID enables 16.7 million unique global networks as well as 256 overlapping networks in a radio area, which contributes to this high density feature. And as for the radio device ID, this enables 4 billion unique radio devices in a single network, as well as 65,000 within a radio communication distance. The MAC layer also handles network routing. So a NR Plus device can be a fixed termination point, which routes devices to other clusters, or it can be a portable termination point, which only sends data. And they can also be both, so a fixed termination point and a portable termination point. Sinks, or the gateways, are always fixed termination points, and then relay nodes have the fixed termination point and portable termination point feature, and then leaf nodes have just the portable termination feature. And if, for example, the sync radio device in cluster 3 is removed and disconnected, the radio devices will automatically reroute to the top sync node, and this happens without interaction from the application layer. So this is handled by the lower layers of the stack, thereby offloading the application. As for what Nordic is offering with regard to NR+, let's take a look at the hardware. So as I said, Nordic is leveraging our existing cellular IoT series, the NRF91 series system and packages, more specifically the NRF91X1 SIP, so the newest generation of devices that we announced this year or launched this year. So we have 3 variants: the NRF9161 system and package, 9131 mini system and package, and 9151 system and package. Where the 9161 system and package is the device that looks most like our first cellular IoT product, the NRF91 series, except it now has support for DECT NR+. And then you have the NRF9131 mini SIP, which is a smaller, lower integration level module. We've taken out the passives and crystals, and so it is not pre-certified, but it is small, and it is a very good fit for NR+, where the certification process is much simpler than for cellular. And the 9151 system and package is fully designed by Nordic, and manufacturing adherence to our supply chain resilience. And it is smaller than the 9161, it's 20% smaller, but these are all software compatible. And the NR Plus kind of feature comes in the form of an alternative modem firmware that you flash to the device. So you can either run cellular modem firmware, or you can run NR Plus. To take a closer look at these devices, the 9161 has support for LTE-M, Narrowband IoT, GNSS, and NR+. It has 1 megabyte flash, 256 kilobytes RAM, ARM Trust Zone, and CryptoCell 310. And it is very similar to the 9160, so there's minimal firmware migration effort. It has a modem that supports multiband LTE-M, Narrowband IoT, and with GNSS or DECT NR+. And it is a small form factor and ultra low power with regard to cellular IoT. With NR+, this would depend a lot on the implementation, but initial numbers show that the NR+ power numbers are similar to the ones for LTE and Narrowband IoT. And for this SIP, we have a development hardware. We have the NRF9161 development kit for firmware development. The 9151 is smaller form factor. It's 20% smaller footprint than the 9161. And it also has support for class 5 output power, so 20 dBm instead of the previous 23 dBm. And it also has developmental hardware in the 9151 DK and the Thingy 91X, which is coming soon. As for the 9131 mini SIP, it is has a 50% size reduction from the 9161, but it is feature and software compatible and is a good fit for NR Plus. It has its smaller, lower price, and it doesn't come pre-certified on the cellular side, but that is not really a concern for NR Plus. And then as for the development kits, as I said, we have the 9161 and 9151. They also come pre-certified for the DECT NR Plus band, and they have a dedicated NR Plus antenna. And among other things, they also have 4 user programmable LEDs and buttons for interfacing. On the software side, what Nordic offers currently with regard to NR Plus is the modem firmware to flash onto the device that supports or that has the PHY, so the lowest layer of the stack, meaning the back layer where I talked about the network topology and the meshing is not included there. Oh, sorry, excuse me. Oh, bit of a cold here in Norway. Okay, so what we offer is the PHY layer, and then for the rest of the stack, so the MAC layer, which has the meshing and the network topology, we work with various solution partners that can offer that. So one of our initial solution partner was or is Wirepass, and they have a product called Wirepass 5G Mesh, which has a focus on smart metering and mains-powered large networks. And this is the stack that is separately licensed from Wirepass, but supported on Nordic hardware. We also work with another company called Link, which has a product, Raven Mesh. And they offer a stack that supports low latency audio, as well as real-time sensors. So ultra-reliable, low-latency communication specifically. And this is a push-to-talk full duplex audio solution. And this is separately licensed from Link Networks, but it is also supported on Nordic hardware. And the last thing we kind of offer is we have support for NR Plus samples and a PHY API available in our SDK in the latest version 2.7.0. So it is possible for customers to build their own stack or solution, but what we offer ourselves is just the PHY interface, and then the MAC would have to be built separately. So to talk a bit more about Wirepass, which we have been working with for a while, Wirepass 5G Mesh is at a 1.0.0 release status. It has general availability. And what they offer with this solution is their own SDK. So it is not Zephyr-based. Wirepass provides you with an SDK to develop your application on top of the Wirepass 5G Mesh solution. And it is separately licensed by them. So anybody who wants to test that has to contact Wirepass Sales. Their focus areas are smart energy and the smart city, smart building. They're focusing on mains-powered IoT applications, so there's no battery operation yet. And for Link, they have RavenTalk low latency audio mesh. This is a software stack that is licensed separately from Link. But they also have an evaluation kit, RavenTalk hardware, for testing. And they support both full duplex and half duplex communication. So if we go back to my initial or previous slide with the applications, this is where our different solution partners are focusing. So Wirepass is focusing on industrial IoT, smart city, and smart metering. And then Link has a solution for professional audio. As for what Nordic offers themselves, we have our NRF Connect SDK, which contains a DECT NR Plus sample for testing purposes, which uses the DECT NR Plus PHY, which is a modem firmware that you flash to the device instead of the cellular IoT modem firmware. This firmware is not freely available anywhere, but it is free of charge, and anybody is able to get it. They just have to go through Nordic sales. And this is because of certification kind of issues. We want people who use the PHY layer to be aware of the limitations of it, because it doesn't have the rest of the radio stack. It just has PHY packets. And we have the sample DECT NR Plus PHY shows a simple broadcast and reception of DECT NR Plus messages between devices on a hard-coded channel. So it's really nothing fancy, but it's a good way to see how to test range and test the lowest layers of the stack. So to summarize on what we are offering right now, we have solution partners, Wirepass and Link, where you can license your a stack. And then we also have a PHY layer and then a modem library, and you can build your own application on top of that using our SDK. Some key takeaways from this presentation. DECT NR Plus is the first non-cellular 5G standard. It is a standard approved as a 5G technology, but it is not a cellular-based technology, so it does not need, you don't need a SIM card, you don't need to go through network operators. Each device is kind of its own base station, and you can set up a private 5G network and own the network yourself and maintain it at a very low cost and scale very easily at a very low cost without needing to go through any network operators like you do with cellular IoT. With the DECT NR Plus standard, you get access to the 1.9 gigahertz global license exempt band, or almost global license exempt band. So you can deploy the same solution globally. And this is a band that is only for the DECT technology, so it doesn't have the same high traffic issues that a lot of other frequency bands for IoT have. So that is a very unique opportunity and unique aspect of this technology. DECT NR Plus is good for massive IoT or low latency operation. It has a low latency and reliability feature that gives you a connection that is almost as good as with a wired connection. And it also has a scalability and density feature, which is very good for massive IoT, where you need to be able to scale very quickly and inexpensively and have very high dense networks. Within Internet of Things, industrial IoT, smart metering, and smart city are the initial targeted applications. For smart metering, we see that this is a very good standardized solution to existing proprietary applications that are already deployed. And for smart city, NR Plus is reliable enough to support or be able to set up an NR Plus infrastructure in a micro city or a contained area like a airport or a retail center. And then it has the capacity to be able to add other devices to that network. It also reuses a lot of cellular techniques. So it's built on proven cellular technology that is proven by millions of devices, cellular devices that are already out in the field today. And Nordic is leveraging our existing NRF91 series, which is our cellular IoT series, to be able to support this standard. Meaning you can get a DK and the PHY firmware and easily be able to have a simple DECT NR Plus network up and running. Yeah, and that was what I had to present to you all today. So I can stop sharing maybe, and we can go to if there are any questions.
Yes, so thank you, Heidi, for your great presentation. We can start with the question and answer section if you want. So the first question is, how does DECT NR Plus compare to other LP1 technologies?
Yes, that is a very good question. So it depends a bit about which LP1 technology one is talking about, but as I said many times, compared to cellular IoT, for example, there is no subscription cost, no kind of need for this existing infrastructure that you have in cellular. You can own and operate a private 5G network yourself. And then for some other LP1 technologies that are out there, NR Plus has a much higher data rate. With our specific bandwidth, you can achieve 3 megabyte per second data rate at a maximum, while still having about a 1 kilometer range. So that makes it very good for applications that maybe need higher data rate. So that's, I would say, one of the aspects where DECT NR Plus compares to other LP1 technologies.
Okay, thank you. Next question is, can I run cellular and NR Plus in the same application?
Yes, so you can run cellular NR Plus on the same application, but not on the same hardware. So although our NRF91 series supports both cellular and NR Plus, these cannot be run simultaneously because they require different firmware to be running on the modem. So you have to choose between NR Plus and cellular IoT. But having two radios and then running NR Plus and cellular IoTs at the same time is possible, and is also very good kind of cellular IoT is a very good option for the backhaul connection to the internet on the gateway of the network, for example.
Okay. And the last question I see is, what do I need to in order to get started with testing DECT NR Plus?
So to get started testing DECT NR Plus, you first need some kind of developmental hardware. For example, the 9161 development kit or 9151 development kit that you can purchase very easily online. And then you will need the DECT NR Plus PHY firmware. So that is a firmware that you can get a hold of by contacting Nordic Sales. It is completely free of charge and easy to get access to. We are just currently not having general availability on that stack since it only contains the lowest layer of the radio stack. So you need the DECT NR Plus PHY firmware, and then you will need to flash an application, a sample that we have in our SDK. And to get started with our SDK, if there are people listening who are not familiar with Nordic, I recommend going to the Nordic Developer Academy, where we have coding courses. We have one called NRF Connect SDK Fundamentals, which you can take, and it will help you install the SDK, get started with the tools we have available, features in VS Code, and get you up and running with that. And then after you've taken that course, you can find the DECT NR Plus Hello sample that is in the SDK and flash that to the device, and then you are up and running. You can also contact, of course, Wirepass and Link, our solution partners, for the fully stack that you can license from them.
Okay. Okay, so I see there's no questions left, but in case you have more questions, or if you are watching the video later on demand and you will have some more questions, feel free to reach out to either me or to Heidi. If you want to have more questions, or if you have more questions or want to check online, you can always check our websites here, or as said, contact me here directly. One more thing to mention is, so this was the last cellular GNSS locationing webinar for this week, and the next one we are doing with the Rutronik Connects is ultra-wideband, LoRa, and edge machine learning webinars later in October. So at October 21st, we will start with Infineon and having Inside ZIP and Ocean, Murata, Kyocera EVX, Edge Impulse, and also Yageo in the same week. And later on, as said at the beginning, in November, we will have a whole Bluetooth week where also Nordic is again talking about their latest Bluetooth technology, and also then the new coming products on NR54, as well as the partner module makers like Inside ZIP or Panasonic talking as well on the NR54 modules. So stay tuned, there's much more coming. The video is getting recorded and getting uploaded later on, and I will send you the presentations next week. So Heidi, thank you for your presentation, and if you do not have any questions anymore, I wish you a good day.
Thank you for having me.
Yeah, thanks.
Bye.
Goodbye.